we're going to talk about what we know already about real numbers. So real number is really everything we've studied so far. We just really haven't called them real numbers. If something's a real number, it would be, you would be able to see it. So I'm going to write any number that would show up on a number line. Okay. So when I say show up on a number line, you guys know what I mean by a number line. If I said graph 2.5, you put a little dot on 2.5. Okay. When we talk about real numbers, what I'd like you to kind of do for me is we're going to do this little diagram. We're going to do it in the back of this paper. If we think of all of the numbers that we study ever in a math class, we've mostly been dealing with real numbers. There are some specific kinds of real numbers. So we have talked about things that are rational numbers. Does anybody remember what it means to be a rational number? You can write it as a what? Yep. Now, some things might trick you, like you might, 1/3 is 0.3 repeating. So 0.3 repeating, even though it's a decimal, is actually it's a rational number because it can be written as a fraction. So repeating decimals, finite decimals, that kind of thing. Then, if we have rational numbers, we also have these things that are called irrational numbers. There's a really famous one. Sometimes people celebrate. Yeah, the number pi is irrational because it has no pattern and it goes on forever. The square root of a number that's not a perfect square, like the square root of 3, for instance, is also irrational. When you type in the square root of 3, don't you get something on your calculator? Alright, does this have a pattern to it? No, there's no like repeating pattern. And the only reason it actually stops is because your calculator screen stops. So those are also things that are irrational numbers. Okay, going back to rational numbers, if we got more specific and we said, okay, what about things like 2/1 or -3/1? Those are called integers. Integers are counting numbers and they're opposite. They're still rational because can't we write them as fractions? Yeah, we can write -3/1, but we don't usually do it. And then if we got more specific than integers, integers are counting numbers and their opposites, right? What are just the positive ones called? Whole numbers. All right. But my point to you is that all of these things that we've studied before in a math class, they all fall under the category of real numbers. They are all kinds of real numbers. What I'm now going to tell you is there are things that are imaginary, which are over here. It's not that they didn't exist before, you just didn't know they existed. And those things make up all of the numbers that we study, and those are called complex numbers. So complex numbers, in a second we're going to give a definition, includes both real numbers and imaginary numbers. Okay, and just so you're clear about the relationship of all those things, that's why I wanted to draw that diagram. But if it's real, it's going to show up on a number line. Alright, so anything that's real. So let's write down some real numbers. We said pi was a real number, right? We said 5. That's a whole number, but a whole number is a real number. Give me a fraction. 3/4. That's a rational number, but it's a real number. This one's irrational, right? Let's throw a negative on there. -8. That would be an integer. These are all examples of things that are real numbers. Okay. Imaginary numbers. Imaginary numbers are things that are non-real, and they come from the square roots of negative numbers. So they have what we said on the other day, an I in them. So I'm going to let I be the square root of a -1, and then we also said that I squared is equal to -1 then. So some examples of things that would be non-real. How about the square root of -25? Do you guys remember from the other day what we said that would be? It would be 5i. Or we can do these things too. What if I asked you to simplify -300? What perfect square goes into 300? Audrey? Yeah, so I could rewrite this as the square root of -100 times the square root of 3. What's the square root of -100? 10. I, right? Times root 3. Okay, so that's imaginary as well. Alright, so complex numbers can be written as A plus BI. Now let me just be clear on this. This is going to be a number. Do you notice that there's no I behind A? We call this the real part. And the part that's next to the I we call the imaginary part. But complex numbers, remember, could be real or imaginary. So let's say, give me a real number. Something without an I in it. 7. Okay. What happens with 7 is the real part is 7. It's like 7 plus 0i, because there's no I part, right? Now, do we write 7 plus 0i? No, because what's 0 times I? 0. But could I write it that way if I wanted to? Yeah, it can be written as A plus BI. So let's write down 7. 7 is an example of a complex number. 2i is an example of complex number. You might see this. 4 minus 3i. Maybe it'll be written like that. Those are all complex numbers. Alright, let's do a few examples. What do you think for the square root of -9? Good. 3i. Alright. We are not leaving any negatives under the radical, and we're simplifying. If you need to refer to your note card, or if you need to refer to the list of perfect squares from the other day, remember this list? Remember that list? Or your root card? Alrighty, what perfect square goes into 200? 100, right? So I'm going to rewrite this as -100, the square root of -100, times the square root of 2. What's this part? Okay, 10i times root 2. Alright, what in the world is this? I to the 4th. Here's how I want you to rewrite them. Let's rewrite them as I squared. Here's why. Up above in my definition, I said I squared is the same as what? -1, right? So if I can rewrite them as I squareds, I can take out those I squareds and replace them. So here we go. I to the fourth, isn't that the same as I squared times I squared? Do you agree with that? And we know I squared is the same as negative 1. So I am going to write this is equal to negative 1 times negative 1. And what is negative 1 times negative 1? Positive 1. So I to the fourth is the same thing as positive 1. Alright, how about I to the seventh? Let's try rewriting these as I squared. Here we go. Let's see, I squared, I meant I to the sixth, agreed, times I. Can't do anything about that I. I'm going to leave it there. But I can replace the I squared. So this is like negative 1 times negative 1 times negative 1 times I. What's negative 1 times negative 1 times negative 1? Negative 1 I. Okay. Next one. What's the square root of negative 64? 8I plus, what's the square root of negative 121? 11I. Hey, they both have I's behind them. Do you think we can put them together? Yep. 19I. That would simplify to B. Okay. Alright, next one. What's the square root of 81? 9. What's the square root of negative 36? 6I. Do you think I can put those two together? Nope. 9 is the real part. This is the imaginary. I'd leave it just like this. Okay. Questions so far?